topic trigonometry is in grade 9 as well as in grade 10. For ICSE students, there is bit of trigonometry in grade 9 and then further application of trigonometry in grade 10. But in CBSE, entire trigonometry is taught in grade 10 only. So this is very beneficial topic for all grade 9 and 10 students, and moreover it is a very interesting topic which has so many real life applications. So children, I'm waiting for everyone to join me. So please join the live stream so that we can learn together and you don't miss out on anything. Okay, so yeah, so I'll just introduce you to trigonometry by the time everyone join in. And if you have joined my stream, write hi in the chat so that I get to know who all are there. Okay, hello Miss Rachna. Yeah, so yeah, so I'm waiting for everyone to join because it's a very interesting topic and I don't want any of my students to miss on this, because trigonometry is something that, as I told you, has many real life applications. I'll give you one example. Suppose there is a sound engineer. It's very important for sound engineer to know the trigonometry, because sound waves travel in repeated patterns. Okay, so when they travel in repeated patterns, the waves are in sine functions, and it's easier for computer to identify the wave pattern, and then sound engineers can also adjust the pitch of the music or volume or anything they want to mix in the waves. So if they know trigonometry, they can do it easily. Oh, hi Ruhan, so I'm so glad to see you. Yes, hello Kartikeya, Ashutosh, welcome to Deep Tips. Yeah. Okay, so this is one example where trigonometry is used, right? So other example is in constructions. So when you make huge bridges, or if you are in construction or architecture, then also you use trigonometry. Then many people must be knowing that they do need trigonometry to know the angles and the sides. Okay, so yeah. So children, I think many of you have already joined, so without wasting any further time, let's start the class. So if you look at this topic trigonometry, I'll do the transition now. The name is derived from Greek word. Okay, so trigonometry is very much Indian, because this was first given by our famous mathematician Aryabhatta. Okay, so Aryabhatta gave the entire trigonometry in a circle, and the trigonometric ratio sine, he called it cotangent. No, ardhjya, sorry. Cotangent was cosine. So Sanskrit, I'm not very good at Sanskrit. Yeah, so Aryabhatta gave the trigonometric ratios to the entire word, but later they were translated into different languages in which word could understand it. We Indians knew Sanskrit at that time, but other people who were comfortable in Latin or in Greek or in Arabic. So I'll tell you that history also in between when we come to the trigonometric ratios, that how the word sine and cosine were derived. I'll come to that. So before that, let's see who all have joined. Yes, so I have Fenris. Hi Kirti. Yeah, welcome everyone. So I was discussing about the basics of trigonometry, so while waiting for you all, so if you look at this word, children, it has tri, then gono, then metri, right? So these words are Greek words. As I told you, it's our Indian trigonometry that was first given by Aryabhatta, but later word adopted the words in their language, and the trigonometry got famous from this Greek word. So tri means three, gono means sides, and metri word means came from Greek word metron, which means measurement. So you can see I have deciphered the word trigonometry, three sides measurement. So now you know which is a three-sided figure. Yes, so everyone know three-sided figure? Yes, it is a triangle. But in trigonometry, we use right angle triangle. Okay, it's very important to know that in trigonometry we always use right angle triangle. Okay, so children, this was the basic introduction to trigonometry and its applications that I was just discussing with you. I want to ask you one more question. Suppose you are standing in a sunny day, bright sunny day, you are standing here and you want to know at what angle the sun is shining in the sky without looking at the sun. Can you do that? Yes. So, yes, high part. So, anybody, you can write the answer in the chat. So, if you want to find the angle at which sun is shining in the sky without looking at the sun, how you will do that? So, this is the question of the day. You can very well calculate it if you know trigonometry. Okay, children. So, if this I am standing in a sunny bright day, I can see my shadow, right? And I know my height. I know the length of my shadow, so I can complete this triangle. You can see I am forming a right angle triangle with the ground. So if I know the trigonometric ratios, if I know the relationship between these two sides of the triangle, I can find the angle at which sun is shining in the sky. Okay, so this is how we calculate. So this is one of the application, a very simple application. So now children, trigonometry gives you the relationship between the sides of the triangle, right angle triangle, also the angles. So let's learn in this live stream that how all these things are related, how this trigonometry is so mesmerizing, and what are so many things hidden in just a right angle triangle. Okay, so as I said that it gives you relationship between the sides. Now I'm going to draw few triangles and you will visualize. Okay, so if I have this much angle, okay, this is the angle theta. I am going to draw 2-3 different type of triangles. Okay, and this is another triangle. Let's draw one more. Okay, this is not a triangle, this is looking like a more like a mountain. Okay, if you look at these two triangles, let's take example. In this triangle, theta is very small. First triangle, theta is small. And look at the length of this side. When your theta increased here, then this length also increased. So that means theta has the direct relationship with this length AB, that when theta is small, so if I take one more triangle where theta is much smaller, so then you look at this length AB, it become lesser. With increasing theta, the length of the side AB increased, and when you decrease the theta, the length of AB decreased. So we can very well see that there is a direct relationship between angles and sides, right? So this is what we are going to learn in trigonometry today. Okay, so I just wanted you to visualize that when I'm saying that trigonometry gives us the relationship between the sides and the angles, that how it is related. So if I am taking this right angle triangle, I will be using the word theta. Theta is also a Greek alphabet that we are going to use here to denote angles, different angles. Okay, so when my theta is small, my perpendicular. Okay, I am introducing 3 words today. I'm sure you have learnt in grade 7 and 8 about right angle triangles when you learnt Pythagoras theorem, that base, perpendicular, hypotenuse. So we know that the perpendicular is altitude of the right angle triangle. So whenever I draw, just a minute, when it comes to draw, I am very bad at it. I'm so sorry. So I'll try my best to draw a beautiful right angle triangle. Yeah. Okay. So now let's learn about the sides of the triangle, that how do we name it. So this is my right angle triangle. Okay, so which is right angled at B. Okay, so we know that hypotenuse is always opposite to 90 degree. So here my triangle ABC is right angled at B. Right? Triangle ABC is right angled at B. So the side opposite to angle B is my hypotenuse. So AC is the hypotenuse. Right? And if I am taking this as theta, now this is very important point. When I am taking angle C as theta, then BC is my base. Okay? And AB is my perpendicular. When I am taking C as the angle theta. Okay, now let me draw one more triangle. One more right angle triangle. Okay, now again this is right angled at B, but now I am taking angle A as theta. Okay, now I am not taking my angle C as theta, I am taking theta at angle A. So now children, hypotenuse remains the same because hypotenuse is opposite to 90 degree. So I know angle B is 90 degree and AC is going to be my hypotenuse. Right? AC is the hypotenuse. But now my base and perpendicular will change because my theta is not the same. Earlier my theta was angle C. So where is my theta? That is my base, where my angle is landing on. Now my angle is landing on A. Okay, so AB becomes my base and BC becomes my perpendicular. I hope everyone is clear with this thing, right? This is very important to understand how to name the sides of a right angle triangle. I'm sure in your previous grades you have learnt about hypotenuse, base and perpendicular, but in grade 9 and 10 the difference is how to change the base and perpendicular with change in theta. Okay, so if you are clear with this, please write yes in the chat. So let me see who all are there. Yeah. Okay, so Ruhan, you are learning trigonometry today. I'm glad you are all already few milestones ahead of your class. Okay, so I hope children you are clear with this concept, that how to identify the sides in right angle triangle. This is the first segment of today's live stream class, that how to identify base and perpendicular when angle is given. Okay, yeah. Okay, so this is one thing. Second thing I want to tell you, that in grade 10 we have angles varying from 0 degree to 90 degree. Okay, but in grade 11 and 12 we do have angles beyond 90 degree, 180, 270, everything we have. But in these streams, in these 7 streams, I'll be focusing on grade 9 and 10 trigonometry. So I'll be doing 0 to 90 degree. When I'll make videos for grade 11 and 12, then definitely I'll cover inverse trigonometry and the angles beyond 90 degree. Okay, yeah. So you are clear with the concept that how perpendicular changes with change in theta, correct? So if you look at these triangles that I was drawing to explain you, now you can connect that with change in theta, perpendicular changes, because every time I choose theta at C, I took theta at C, point C. So this was my base every time. BC was my base. So perpendicular, the length of the perpendicular was changing every time with change in the angle theta. Okay. Then we understood how to identify the sides in the triangle. Okay. Yes, Parth, perpendicular is the height. Okay. Now next thing is trigonometric ratios. Trigonometric ratios are very important. Okay. So trigonometric ratios were first given by Aryabhatta. I'll tell you a brief about it. You must be wondering when I'll tell you about Aryabhatta. So when Aryabhatta first gave us the trigonometric ratio sine, he called it Ardhjaya. You know what is the meaning of Ardhjaya? Ardhjaya in Sanskrit means half chord. Now you must be wondering, here we are talking about triangles, but when I am talking about Aryabhatta, I am saying half chord, and chord is the part of a circle, correct? And yes, you are thinking it right. Chord is part of circle, and Aryabhatta gave the entire trigonometry in circle. And children, I'll be covering few live streams where I'll explain you sine, tangent and cosine in a unit circle. Not today, but in later streams we'll discuss about it, that how this Ardhjaya, he gave us a very useful sine wave in a circle. Okay, so it was called half chord in India, Ardhjaya, in Sanskrit, but then Arabic people took it from us. Okay, and they called it Jiva. So Ardhajaya was called Jiva in Arabi. Okay, then it was then translated to a word sinus. Sinus means curve. See, curve also comes in a circle. So from Ardhajaya to Arabic Middle East, it was called Jiva, and then translated to word sinus. Sinus means curve. Okay, then in Latin it was called sine, and the abbreviation that we are using today is sin. We don't call it sin, it is called sine. So sine theta. This is how from Sanskrit word Ardhjaya it got translated from Middle East to Europe, and then in the entire world it is called sine theta. Okay, this is the history of first trigonometric ratio sine. And then he gave cosine. Aryabhatta only gave cosine, and he called it cotangent. See, you can relate it. The sine he called Ardhjaya, and here he called cosine as cotangent. And if you look at the word here, cosine, co means complementary. You know what are complementary angles? Yeah, when sum of two angles is 90 degree, they are called complementary angles. So cosine is complementary of sine theta. This also I'll teach you in one of the live stream, because it's difficult to relate everything in one plate, then your plate will overflow. So I don't want to let you feel like it's overflowing, so we'll learn everything step by step. Okay, so today I'll introduce you to trigonometric ratios, but in my further live streams I will be giving you reasons for the names sine theta, cosine theta, and why are they called. So I'll cover all these things, don't worry. Okay, so but now I'm going to tell you a very nice thing that I learned in my school days. Okay, so you can repeat with me also. It is Pandit Badri प्रसाद हरि हरि बोले सोना चांदी तोले. Okay, पंडित बद्री प्रसाद हरि हरि बोले सोना चांदी तोले. You must be thinking, what is she saying? Yeah, out of this word, from where this Pandit Badri Prasad came. But children, just mark my words, this is the mantra to do trigonometry in exams. This is how I did it my exams. Pandit Badri Prasad Hari Hari Bole Sona Chandi Tole. This is how my teacher taught me in grade 10. So I am just passing on this knowledge to all of you. Now see here, P means perpendicular, B means base, and H means height, hypotenuse. Sorry, yeah. So perpendicular, base, and hypotenuse. I have these three sides in my right angle triangle. Now let's try to understand what is this Pandit ji trying to say. Okay, so here is my right angle triangle ABC. Okay, and let's take this angle theta. So when I say sine theta, so what is the ratio of what is this trigonometric ratio sine theta? That means which two sides I shall take to write the ratio sine theta. We know ratio is comparing quantities. So here in this right angle triangle, I am comparing the lengths of the sides. Correct? So when I am taking this sine theta angle or sine theta trigonometric ratio, I have to take perpendicular upon hypotenuse, P upon H. Okay, so that's why I said Pandit Badri Prasad Hari Hari Bole Sona Chandi Tole. So S is my sine, C is cosine, and T is tangent or tan. Okay, so sine theta is perpendicular upon hypotenuse. So here this is my hypotenuse, this is my base, and this is my perpendicular. Okay, so now perpendicular upon hypotenuse means AB upon AC. Correct? I hope everyone is clear. So when I say cos theta is base upon hypotenuse. So Pandit ho gaya P perpendicular. Now B base. Okay, so my base is BC here and hypotenuse is AC. Correct? Now tan theta is perpendicular upon base again. So perpendicular is AB and base is BC. So now you understood my mantra. This Pandit Badri Prasad Hari Hari Bole Sona Chandi Tole. So this Sona means sine, which gives me perpendicular upon hypotenuse. Cosine is base upon hypotenuse and tangent is perpendicular upon base. So that's why I got my sine theta, cos theta and tan theta by just looking at this. Okay, so if you write this in your rough column in the exam, it becomes very easy for you to remember these trigonometric ratios. Okay, so now if you look here children, one more thing we are going to derive. Tan theta is equals to AB upon BC, correct? Perpendicular upon base. So what is sine theta? Sine theta is perpendicular upon hypotenuse and cos theta is base upon hypotenuse. Right? Now if you solve it further, both the hypotenuse get cancelled and this is equals to perpendicular upon base, which is AB upon BC. So that's why we write that tan theta is equals to sine theta upon cos theta. So this is the reason why tan theta is equals to sine theta upon cos theta. Yeah. So if you are clear with the concept, please show me thumbs up in the chat or write yes. Or if you have any doubt, please don't hesitate to ask me a question so that I can repeat where you are stuck or where you are not clear, because this is the benefit of live stream. It's more like a classroom teaching where you can ask me questions in the live chat and I can answer your questions. I hope those who are connected with me are clear with this Pandit ji mantra and how to write the ratios, trigonometric ratios, sine, cos and tan. I am not done yet because there are total 6 trigonometric ratios, but we have only written 3 yet. So I just want to know if you people are clear what we have done so far. Okay, so let's see, someone has shown me thumbs up. Okay, Part, great to know that. I hope others are also clear. Yes, so now when I have written sine, cos, tan, children, there are, if you do the reciprocal of these ratios, you get, okay, cosecant, yeah, 1 minute, okay. So for reciprocal of the ratios of sine theta, we get cosecant theta, that is AC upon AB. So here I am connecting sine theta with cosecant theta, okay. Then tan theta, if you do the reciprocal, you get cot theta, cot cot, that is cotangent. So BC upon AB. And for cosine, you get secant theta. Secant theta is AC upon BC, okay. So this is how we do this, okay. So reciprocal of sine theta gives you cosecant, for tan you get cot theta, and for cos theta you get secant theta. So these are the main 6 trigonometric ratios. So I am writing all here: sine theta, cos theta, tan theta, and here cosecant theta, secant theta, and cot theta. So these are the main 6 trigonometric ratios that are in the syllabus of grade 10, okay. Now like I told you, with the change in the angle, your ratio also changes. So earlier we took, 1 minute, I'll draw and then I'll connect, yeah. So here ABC, in the previous diagram I took theta here, correct. Now if I take, yeah, if I take, just a minute, theta here, now I am taking angle A. Earlier I took angle C and we found all the trigonometric ratios. Now I am taking angle A. So what is the difference now? Hypotenuse will remain same because it is opposite to right angle, but base will become AB and BC will become my perpendicular, okay. So this is the difference. So just for practice, let's do once again sine theta, cos theta, tan theta. I'll write it here only. So first we'll write our mantra: Pandit Badri Prasad Hari Hari Bole Sona Chandi Tole. Okay, now looking at this, I want everyone to write down quickly sine theta, cos theta, tan theta, and then cosecant theta, secant theta, cot theta. Okay, so sine theta is perpendicular upon hypotenuse. So here my perpendicular is BC and hypotenuse is AC. Okay, now cos theta. Cos theta is base upon hypotenuse. My base is AB and hypotenuse is AC. Okay, now tan theta. Tan theta is perpendicular upon base. So my perpendicular is BC now and base is AB. Correct? Now when I have to write cosecant theta, cosecant is just ulta, reciprocal, AC upon BC. Okay, so cosecant theta is hypotenuse upon perpendicular. So hypotenuse is AC, perpendicular is BC. That's why I wrote AC upon BC. Now then secant theta. Secant theta will be reciprocal of cos theta. So I can write AC upon AB. Okay, and cot theta will be AB upon BC. So everyone clear how to change the ratios with change in angle? Because this is very important in introduction of trigonometry to understand the sides. Okay, then first to identify the sides, that how to label the sides with the change in angle, and then understanding the trigonometric ratios. So we have sine theta, cos theta, tan theta, and then cosecant theta, secant theta, and cot theta. So these are the main trigonometric ratios. Okay, so now children, if you have any question to ask, you may ask in the chat. I'm telling you again and again, don't keep your doubts to yourself. Okay. Okay, so I think we are clear with the concept of trigonometric ratios. Also, one thing I want to tell you, that with the change in the length of the triangle, the ratios doesn't change if angle remain the same. So if the sides length of the sides changes but angle remains the same, then trigonometric ratios values does not change. Okay, so because it depends on the it is same as similar triangles that you have done in grade 10, where suppose if you draw two triangles, okay, where your angles are same. If these angles are same, if these are 30 degree, then value of sine 30 degree will remain same. It doesn't depend on the length of the triangle sides. Okay, so now let's do few questions to understand more about the ratios that we have learned today. Okay, so first question is, if cot theta is equals to 7 by 8, okay, find 1 plus sine theta into 1 minus sine theta upon 1 plus cos theta into 1 minus cos theta. Okay, so if you look here in this question, they have given you the ratio cot theta. Okay, so let's draw a right angle triangle. Okay, so here this is my triangle which is right angled at angle A, fine, and this is my theta. So I know when I have my theta at B point at angle B, so AB is the base, correct? Yeah. So now if I look at my Pandit Badri Prasad Har Bhole Sona Chandi Tole, I know my tangent is perpendicular upon base. So cot theta will be equals to base upon perpendicular, which is the reciprocal, right? If tan is perpendicular upon base, cot will be base upon perpendicular, correct? This everybody knows. So now here cot theta is equals to 7 by 8. That means my base is 7 and my perpendicular is 8. So this is 8. So everyone is clear with this. Now we know that in right angle triangle, if two sides are given, how to find the third side? Using Pythagoras theorem, right? Okay, so BC square is equals to AC square plus AB square, correct? This is what Pythagoras theorem says. So BC square is equals to AC square is 8 square 64 and 7 square is 49, which is equals to 113. So BC is equals to root 113. So I know all three sides, correct? So I can find sine theta now. So sine theta is perpendicular upon hypotenuse. So my perpendicular is 8 and hypotenuse is root 113, correct? And in the question they are asking 1 plus sine theta and then cos theta is also there in the denominator. So cos theta is base upon hypotenuse. See, this my Pandit Badri Prasad is really helping me out, because otherwise it's really difficult for me to think, okay, whether it was P upon H or H upon P. So if you write this in the beginning of the trigonometry, half of your problem is already solved. Then there is no chance of making mistake in writing the value for sine cos tan. Okay, so now I know cos theta is base upon hypotenuse. So my base is 7 and hypotenuse is root 113. I can substitute this in my question and I can find, but I will not directly blindly start substituting the values. Why? Because I know 1 plus sine theta into 1 minus sine theta is same as a plus b into a minus b. Correct? So a plus b into a minus b gives me a square minus b square. So I can write it as 1 minus sine square theta, and in the denominator I can write 1 minus cos square theta. Correct? So when I am writing sine square theta, it means 8 upon root 113 whole square upon 1 minus 7 upon root 113 whole square. Okay, so when we solve this, it is 64 upon 113 upon 1 minus 49 upon 113. See, don't make mistakes in calculating the fractions. So this is 113 minus 64 upon 113 minus 49. So 113 get cancelled in between. So 113 minus 64 gives me 49 and 113 minus 49 gives me 64. So this is the answer. So 1 minus sine square theta upon 1 minus cos square theta gives me value 49 by 64, which is same as cot square theta, right? If I do cot square theta here, it is also equals to 49 by 64. So that means this cot square theta is directly related to this. It is equals to 1 minus sine square theta upon 1 minus cos square theta. Okay, so I hope you are clear with this question, that when one trigonometric ratio is given to you, you can find the remaining 5 trigonometric ratios from that. Okay, so let's see who all are connected with us. Yeah, okay. Hi Umang. Yes, you can definitely see this video. Okay, I'll try to explain in Hindi also in between so that everyone understand it. Okay, I hope everyone is fine with Hindi. So language should not be a barrier in understanding math, because math is such a subject which has nothing to do with the language. You agree with me? Because math is something that is not expressed in any language. It is a kind of, Einstein said it is a poetry of logical ideas. So mathematics is a poetry of logical ideas. So logical ideas are expressed in numbers. So language should not be a barrier. So I hope everyone is okay with Hindi. Yes? Okay. So next question is, find tan P minus cot R. ओके, इस क्वेश्चन में हमें एक ट्रायंगल भी दी है. वी हैव अ ट्रायंगल हेयर जिसमें वी हैव एंगल पी आर एंड ओके P here, R here and Q here. And this triangle is right angled at Q. Okay, what is Parth saying? Okay, so Parth is saying if I teach in Hindi, 90% people will not watch. Parth, teaching in Hindi doesn't mean that I will start writing anything in Hindi, because I myself have not learned math in Hindi. Okay, so it just means explaining here and there a little bit in Hindi, that we do in class also, right? Okay, so here we have angle P, angle R, and angle. This triangle is right angled at Q. Okay, so if this is given 12 centimeter and this is 13 centimeter, so you can find QR. Length of PQ is 12 centimeter, और पी आर की लेंथ है 13 सेंटीमीटर, करेक्ट. सो इफ वी हैव टू फाइंड क्यू आर, वी कैन यूज पाइथागोरस थ्योरम अगेन. So QR square is equals to PR square minus PQ square. So PR का square करेंगे तो 13 square is 169 minus PQ square and PQ square is 144. So 169 minus 144 is how much? You can write in the chat that 169 minus 144 is how much? It is 25, right? So QR square है 25. So अगर हम इसका square root करें, if we take the square root of 25, we get 5. So length of QR is 5 centimeter. Okay. Now, like I explained you in the beginning, that when we find tan P, that means I am looking at this angle. Okay. So for tan P, let's write our Pandit Badri Prasad. I am very much dependent on this. Pandit Badri Prasad, Har Har Bhole, Sona Chandi Tole. Why I am writing it again and again? So that you get used to it. Okay. So here tan is perpendicular upon base. So जब हम ये एंगल P ले रहे हैं तो PQ is the base. Okay. And QR is the perpendicular. And PR will remain hypotenuse in both the cases, correct? So tan P is perpendicular upon base. So perpendicular क्या है 5 centimeter and base is 12 centimeter. So tan P आ गया 5 by 12 tan P ratio. Okay. Now we have to find cot R. Now when I am saying angle R जब हम देखेंगे, that means my base will change because now I am looking at this angle R. So this is my base. Okay. And this becomes my perpendicular. Okay. So cot R is reciprocal ratio of tangent. Correct. So this is base upon perpendicular. So my base is 5 and my perpendicular is 12. So cot R ka value is 5 by 12. Now they are asking find tan P minus cot R. So here 5 by 12 minus 5 by 12 gives me 0. So answer is 0. Now did you notice something? That here when I found the value for tan P, it is same as the value for cot R. So we'll solve this mystery in our next live stream, that what are complement angles and how with the change in angle the other angles, reciprocal angles, are equal. So we'll learn this in our next stream where I'll address this topic, complementary angles. Okay. So here for now in today's first stream, I am focusing on how to find the trigonometric ratios. Okay, that how to identify the sides of the triangle and how to find the trigonometric ratios. Now let's do one more question which is a different one. Okay, and this question says, third question, that in triangle PQR, which is right angled at Q, PR plus QR is equals to 25 centimeter and PQ is 5 centimeter. Okay. So we have to find sine P, cos P and tan P. So if you look at this question, they are saying we have a triangle PQR. Okay. So just a minute. Yeah. PQR, which is right angled at Q. तो एक राइट एंगल ट्रायंगल लेंगे जिसमें 90 डिग्री एंगल क्यू पे है. ओके. और क्वेश्चन में क्या गिवन है, दैट सम ऑफ द साइड्स पी आर एंड क्यू आर, मीन्स अगर हम पी आर और क्यू आर को ऐड करें तो दैट इज 25 सेंटीमीटर. सो दिस इज गिवन इन द क्वेश्चन. और सिर्फ एक ही साइड की लेंथ हमें गिवन है, दैट इज पी क्यू विच इज 5 सेंटीमीटर. So PQ is 5 centimeter and PR plus QR is 25 centimeter. So we have to find sine P, cos P and tan P. So let's take P down so that it's easier for us to assume the base. Okay, I'll write P here because it doesn't matter where I write P and R. The thing that matters is right angle. तो क्वेश्चन में जो भी राइट एंगल दिया है, प्लीज लुक एट दैट केयरफुली टू मार्क. इफ इट इज सेइंग दैट इट इज राइट एंगल एट क्यू, यू शुड नॉट मेक राइट एंगल ऑन पी, देन द होल क्वेश्चन विल बी रॉन्ग. सो व्हेन इट इज सेइंग राइट एंगल एट क्यू, सो हमें राइट एंगल क्यू पे ही बनाना है. Okay, then we have to definitely make angle at Q. Suppose if I make a triangle like this and I write here P and Q here, R here, then whatever I do, my question will be wrong from the beginning. Examiner will not check your question if your diagram is wrong in geometry. Okay, so please be very careful about the diagram while solving questions of geometry. Okay, so now here angle Q is 90 degree and QR is, okay, PQ is 5 centimeter, not QR. Okay, yeah, so this QP is, or PQ is 5 centimeter and PR plus QR gives me 25 centimeter. So now here the question is ki ab how to find QR and PR, because without that it is not possible for me to find the value of sine P, cos P and tan P, because these trigonometric ratios depends on my sides, length of the sides. So it is important to find length of the sides first, correct? So right angle triangle hai, to Pythagoras is there to help me out, right? So I know that PR square is equals to QR square plus PQ square. Everybody knows this, correct? So PR square equals to PQ square plus QR square. Now I have QP square or PQ square, so I can write PR square minus QR square is equals to PQ square. Okay, so this thing PR square minus QR square, you can think it in the form of algebra, A square minus B square, right, which is equals to A plus B into A minus B, which is equals to PQ whole square, that is 5 square is 25. Now PR plus QR जो है, that is 25 centimeter already given, so I can substitute here 25 and here PR minus QR equals to 25. Now if I take 25 on the other side, I get PR minus QR equals to 1. So now you can see here I got two linear equations, correct? So this is my first equation and this is the second equation. If I solve these equations, I'll get the length of my sides. So let's solve these. PR plus QR equals to 25 and PR minus QR equals to 1. So when I add them, they get cancelled, and here 2 PR is equals to 26, which implies PR equals to 26 by 2 is 13 centimeter. So here I have PR as 13 centimeter and I know my Pythagorean triplets. Yes, and those were not actually Pythagorean, those were Brahmagupta's triplets, which Pythagoras learnt and taught his disciples, and then from then onwards it was known as Pythagorean triplets. Okay, anyways, so yeah, and I want to say that on 16th of December entire world celebrates the Pythagoras day, so that day we'll have a special class on Pythagoras. Okay, so we'll learn something, some of his achievements and the things that he taught to the world and the different applications. So 16th of December we'll dedicate it to Pythagoras. He was also a great mathematician. Okay, so here PR is 13 centimeter. So you can calculate also RQ by substituting this 13 centimeter. Okay, or you can write here 12 centimeter if you know the triplets already. So then my QR is 12 centimeter. Now if you look here, I have to find sine p, cos p, tan p. So this is my base, this is my perpendicular, and this is my hypotenuse. Okay, so sine p is, yes, perpendicular upon hypotenuse, so which is equals to p upon h. Perpendicular is 12 and hypotenuse is 13. And what is cos p? Cos p is base upon hypotenuse, so base is 5 and hypotenuse is 13. And tan p is sine upon cos, also you can do, or you can do perpendicular upon base. Perpendicular is 12 and base is 5. So this is how we find the trigonometric ratios when two sides are given, or one side is given, or some equation is given. So this is how we solve this. Okay, yeah, so we are done with today's session on trigonometry introduction, or introduction to trigonometry. So we learned how to identify the sides of the triangle, right angle triangle, when angle changes. And then we learned different trigonometric ratios, 6 trigonometric ratios, how they depend on the sides of the triangle. So children, this is a very interesting topic, trigonometry. Starting from the introduction, we will do till the application of trigonometry. Okay, heights and distances. So this is the first stream. Very soon I'll come back with second stream, and then we'll learn about more about trigonometry. So keep watching Deep Tips, share my channel, subscribe to it so that you learn with me. Okay, so thank you for watching. Stay tuned on Deep Tips. Thank you so much.